Okay, hey guys, this is going to be our, how do I make this bigger here? Chapter 11 review for today. Okay, so first thing I want to do, we're reviewing volume, and I just want to make sure that you guys have a good understanding of what volume even is, okay? So the volume of a shape is the amount of space it takes up. So it's going to take up space in 3 dimensions, okay? A length, a width, a height. So it's a 3-dimensional shape, okay? So if we're trying to figure out how much space it takes up, our units are always going to be cubed. So a cylinder might be 20 centimeters cubed, or a pyramid, its volume might be 30 meters cubed. Okay, so what is a meters cubed, or what is a centimeters cubed? What does that even look like? So I think this Rubik's Cube here can give us a really good idea of what volume looks like, okay? So this is a prism. Remember, a prism is gonna have a parallel, 2 parallel bases, okay? So this is a prism. It is a square prism because the base is a square, okay? You'll see that this prism is made up of a bunch of cubes, okay? A cube, another cube, another cube, okay? How many cubes are there? There's 27, okay? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 cubes here on this top level. There would be another 9 cubes on this medium level, and another 9 cubes on this bottom level. So this prism, if we assume, and I didn't actually measure these, but I'm gonna just pretend that this cube here is a centimeter by a centimeter by a centimeter. So we're gonna say each one of these cubes is 1 cubic centimeter, or 1 centimeters cubed, okay? And then I have 27 of those cubes. So the volume of this prism would be 27 centimeters cubed, or 27 cubic centimeters, okay? 27 cubes that are a centimeter by a centimeter by a centimeter. Okay, so this is just one example. This is a prism. You might be thinking, well, how does a cube actually fit nicely into like a cylinder? And it might not fit nicely into there, but you can kind of imagine, like, if part of the cube is cut off, that extra part would be also in that cylinder somewhere. So the volume might not be nicely, a cube might not fit nicely in there, but you can kind of think of the cubes as like flexible. And if a cylinder has 27 centimeters cubed, it means I could kind of mold this and fit it into the cylinder, okay? So think of it as like Play-Doh, which is kind of flexible. Believe it or not, I have Play-Doh sitting right here for you, okay? So right now the Play-Doh is kind of in the shape of a cylinder. I can take that volume out and I can make it look like a cube, or I can make it look like a cone, okay? So you wanna kind of think of volume as it takes on different shapes, okay? But it's always measured in a unit cubed, okay? A cubic unit. All right, so we're gonna review how to do a volume problem. So the first thing I want to remind you of is what our 4 shapes look like. So we're gonna look right here. Move this, okay. So here are all 4 of our shapes that we wanna be able to find the volume of. We have a prism here first, okay? Remember, a prism has 2 parallel bases, okay? And then a pyramid, which is gonna come to a point at the top, and then a cylinder and a cone. A cone looks like a cone. Think of an ice cream cone, or like an orange cone that you see in a road. Okay, so those are our 4 shapes, and then you can see the volume formulas right next to those. So for a prism, it says volume equals capital B times H. And the very most important thing to remember is that capital B, I've highlighted it right up here at the top, Capital B stands for area of the base. That is not a number that you're gonna find on your shape. So it's not like you look at the shape, you find capital B and you plug it in. It's not gonna be on the shape. You have to figure it out, okay? You have to calculate it. So capital B is something that you're going to have to calculate. So if your base is a triangle, you're gonna have to find the area of that triangle. Once you find the area of that triangle, that answer is your capital B. So capital B is something you have to calculate, okay? So let's give that a try. We're gonna do one problem, and this problem came, I got Play-Doh everywhere. This problem came right from your quiz, okay? So let's take a look at that really quick. So you did a quiz over volume, and we are going to do the hardest problem, what I would consider the hardest problem, together, just to kind of refresh your memory and make sure you understand how to do volume. So we're gonna do number 3 right here. Number 3, we have a pyramid because it comes to a point at the top. Okay, so we wanna find the volume of that pyramid. Okay, it tells us JM, or this side length, is 6. And it also says that this is a square pyramid, meaning the base is a square. So if I have 6 on this side, JM, ML is also gonna be 6, KL is also gonna be 6, JK is also gonna be 6. Okay, and then it tells us IN, which is this slant height, is 5. That is not your height. It is your slant height, okay? So let's go ahead and attempt this problem. Okay, all right, so we are going to be finding the volume of that pyramid. And the volume of a pyramid, if you follow the formula, it's always 1/3 capital B H. Okay, again, capital B is not a number that you're gonna find on your shape. It's something you're gonna have to calculate. It stands for area of the base. And remember, the base of our pyramid was a square. Okay, so we have to find the area of that square. How do you find the area of a square? Just do length times width, or you could say base times height. Okay, so let's go ahead and do that. Remember, the square was 6 by 6 by 6 by 6, right? Or I should just say 6 by 6, okay? All of the side lengths of the square were 6. So the length of the square is 6, and then the width of the square is 6. So I just found the area of the square. Length 6 times width 6. So this is my capital B. Okay, and now I need the height of the pyramid, which they did not give me. They did not give me that height. Instead, they gave me the slant height, which was 5. Okay, I know from that center out to the edge, that's going to be 3, because the entire side length is 6. So from the center out to the edge is half of 6, or 3. Okay, to find this height, we're going to do the Pythagorean theorem. So h squared plus 3 squared equals 5 squared, or h squared plus 9 equals 25. Okay, and then we are going to subtract 9 from both sides, and we get h squared equals 16. Okay, take the square root of both sides, and we get height is 4. So this height is 4. So I'll plug that in for h. Okay, and now I'm going to use my calculator to find the answer. Okay, so I'm going to do 6 times 6 times 4 and hit enter. So if I multiply these 3 numbers together, I get 144. And then I need 1/3 of that. So I can multiply by 1/3, or I can just divide by 3. See how this is dividing by 3? So go ahead and do that. Divide by 3. We get 48. So our final answer is 48 inches times inches times inches is inches cubed. So again, what does that mean? It means inside that pyramid, I could fit 48 cubes that are an inch by an inch by an inch, okay? Now, the cubes won't fit nicely in there. You want to think about Play-Doh, right? I would have to take 48 cubic inches and I'd have to mold it to fit into that pyramid, okay? Alrighty, thanks guys. That is our volume review.